Good morning.
Good morning, sir.
So again, I request all of you to use your institute MS Team user ID and password in order to attend my class. There are some students because it is just second week of your class. That is why I admit it. And later on, I do not admit if you try to attend from other your personal ID, right? Okay, so one question came, if you are having any doubt, then how you address that? Definitely you can address because there are several ways where you can address the doubts. Okay, so
Yes, sir.
one way is you please email me. Another way, I will give you opportunity in the last maybe 5 minutes where I can discuss it. And all of you get the lecture note, then I think it is more than sufficient to understand the things, whatever it is there. And I request you to attend the lecture very carefully. So I try to attend every queries, whatever it has been mailed me during my lecture. Okay, so now I do not allow your mic.
Sir, also disable the reactions.
Yeah,
Sir, that emoji, that portion.
hello. Okay, so today I will start with one exercise particularly. You see the domain of definition where basically D is your domain of definition, where we have to find the integration of this function. X e to the power twice y dx dy. So this is a double integration, and you know that this domain is particularly type 3 region. Why it is type 3 region? Because we can express this particular region as either type 1 or type 2. That is why it is known as the type 3 region. You see, I can evaluate this integral in by means of iterated integral. What is that? That is, if we go in this direction, then x is running from 0 to 2. That is your x. And y is running from where y is here 0. Here it is x by 2. So 0 to x by 2. And x e to the power twice y. Then it will be dy and dx. Okay, so in this way we can do. That is one. Another way also we can do, or it is same as if we go along this direction. That means what? That means what is the range for y? Y is 0 to 1. And what is the range for x? X is here twice y. X is twice y here. This is your x. And this is your x is 2. So x to the power twice y. It is dx dy. So you can do either of the thing. Whatever the thing, it is easy that you have to do. Whatever you find easier, that you try to do. Okay, so this is your home exercise. Rest of the thing. Is there any problem it happens?
Yes,
Yes,
sir.
sir.
Sir, screen is not shared. Sir, screen is not
Green
visible.
light is not
Green is not visible, sir.
not visible here.
Sir, screen is not visible.
Your voice not coming, sir. अभी तक कुछ भी सर नहीं दिखा.
We are not sharing screen, sir. Sir, screen is not shared.
नहीं भी नहीं है.
Now it is visible or not?
No, sir.
No,
No,
sir.
sir.
No,
No,
sir.
sir.
No,
No,
sir.
sir.
No,
Not
sir.
No, sir. Sir,
Screen
can
is
you
not
repeat
visible.
again, sir? Allah.
Yes, sir,
You,
screen is not visible.
Yes, sir.
Yes, sir.
Not
Not
visible,
visible.
sir.
What is sir? Yes, sir.
So now it's visible.
Yes, sir. Now visible.
Yes, sir, now visible, sir.
It's like a black screen, sir.
It's like
now,
a black
Yes,
screen.
sir.
How is
Sir,
it?
yes,
Yes, sir,
Now
now.
it's
Yes,
visible.
sir,
Now
now
visible.
visible,
Sir,
sir.
it's now visible.
sir, start with your
Visual, sir.
Sir, start with.
Explain again,
Sir, at
sir.
least you should allow two boys or two
Yes,
girls
sir.
again, sir. That will complain the issue. Otherwise, the issue will not be fixed, sir. At least you should allow two boys or two girls.
Explain again, sir.
Explain from the beginning.
Sir, allow only the CRs with their mic
Yes,
on.
sir. Allow only the CRs with their mic. Otherwise,
okay, so I request on, is there any option for that? Okay, so it may be taken care of in the next class. Again, I explain it. Suppose the question is this one. We have to integrate. This is your double integration, and region of integration is like it is given in the picture. So it is joining. This is a triangular region. It is joining 0, 0, 2, 1, and 2, 0. So this region is basically a type 3 region. Why it is type 3 region? Because it can either be expressed as type 1 or be expressed as type 2. That is why it is a type 3 region, right? So now if in order to integrate this double integration, in order to evaluate this double integration, what we have to do, we have to find by means of iterated integral, right? So in this case, if you look at in this direction, so x is running from 0 here and x is 2. So x is in between two constant. It is 0 to 2. That is your right hand most limit. And what is y? Y is here 0, y equal to 0, because at any point, if you take at arbitrary point, it is x comma 0. So y equal to 0, and whatever the point here, sample point, that is x comma x by 2, because it is 0 comma 0 to 2 comma 1. This is a line segment. If you draw the picture, draw the line straight line segment and its equation, you will understand that it is x by 2. So 0 to 2, 0 to x by 2, this is dy and then dx, right? So you can either find this repeated integral, or you can find in this direction also. So what is that? 0 to 1, what is your y? And this is up to 0 here, up to 1. So 0 to 1 for y, and x is here, whatever x, it is a sample point twice y comma y. So x is equal to twice y. Here what is x? X is equal to 2. This is a constant. So x equal to 2 is this line segment. So twice y to 2. Then you have to integrate with respect to x first and then y. So either of the two you have to do it. Okay. Now I like to describe one important theorem in this respect. This is known as the Fibonace theorem. What it says, if f is integrable, you can see this one. If f is integrable on r is what? Closed interval a comma b cross c comma d. then either of the iterated integral, if it exists, equals the double integral this thing. So we have to understand whatever the things it is there. First one is if f is integrable on a domain of definition R, rectangular domain of definition, then either of the iterated integral, if it exists, it has to be equal to the double integral this. Okay, so we have to very carefully understand this thing, and there are certain remarks also we'll do. So first corollary, one, it says that if f is continuous on R, then we can get the very ideal situation. Then both the iterated integrals exist and they are same. So this is important thing. So this is very ideal situation. Now look at it here. Whatever the function x e to the power twice y, this function is continuous function, continuous on the region of integration R. Okay, or any other case. Then we can say that both the iterated integral exist. So you can do either of the two. Then another corollary I can have in Fibonace theorem. If both the iterated integral exist, then they are same. So if I take one example here, if I take this one, particularly x to the power y, this if I consider on 0, 1 cross 0, 1, then if I do this 0 to 1, 0 to 1 x to the power y dx dy, or 0 to 1, 0 to 1 x to the power y dx dy, sorry, dy dx, then both the iterated integral do exist. These are exist. We can say from this corollary that these are exist. These will exist. But what happens if you see, if you try to calculate it 0 to 1, 0 to 1 x to the power y dx dy, this is easy to calculate. This is easy to calculate, and it is going to be equal to ln2. If we look at the other iterated integral, so what is the other iterated integral? This is 0 to 1, 0 to 1 x to the power y dx. If we integrate with respect to x first, keeping y as constant, then y, then this is difficult to calculate. This is difficult to calculate or find, but it will also be same as ln2, right? So in this case, what we are getting the advantage? We are getting the advantage that in some of the double integration situation, if both the double integral exist and the function is integrable, then we can say that both the iterated integral have to be same. So we can find either of the two. So you have to take the decision which one you are going to calculate, which one will be easier. That only you have to calculate in order to find the double integration. So this is also important thing, important observation from the Fibonace theorem. So there may be the case, another remark I can write. I use different color. So remark 1. Both iterated integrals exist, but double integral may not exist. And this thing doesn't contradict Fibonace theorem. Okay, now my question is why? Why there may be a situation where both iterated integral exist, but double integral may not exist. And at the same time, we can say that this does not contradict Fibonace theorem. Okay, just I like to allow my. So before allowing mic, I like to tell you, just whoever I ask you, that he or she will answer it. Rahul Kumar,
Sir,
Sib,
slide is not showing.
no. If I ask you, then only you have to answer it. Rahul Kumar, you are there?
Sir.
Yes, please answer.
Sorry, just the network error, sir. I just don't know the questions. I was penning it in laptop, but it's not penning link. It is in mobile, so it's getting difficult to see it. One more time questions.
Okay. So my question
Sir.
is that no talking. I'm talking to Rahul only. Again, I repeat my question. So there may be a case where both the iterated integral exist, but double integral may not exist. That is one part. Another part is that in this fact, we can tell that Fibonace theorem is not contradicted. And you have to tell why.
Unable details.
So because they may have different values and they can exist even also.
Okay, so I will be giving answer.
Sir, I can explain with an example that only.
Sir, they can exist, but they may have different values. So if they have different values, then double integral will not exist. But they will be existing as different values.
Sir, if they are discontinuous, then
Sir,
Uh,
because difference between iterated integral and double integral.
exist.
Not have finite value.
So
Okay, so thank you very much for your answers and different try. And now I like to explain it. So once again, you try to have a look at the theorem statement. If f is integrable, if the function integrand function is integrable on R, then either of the iterated integral, if it exists, it has to be equal to the double integration. Okay, so there is a supposition. What is that? If the function is integrable. So if the function is not integrable, then you cannot give the guarantee, right? That means you have to find a situation where the function is not integrable, but iterated integral, both the iterated integral exist. Okay, so this may happen like now I am in a position to give the example. So look at this thing 0 to 1, 0 to 1. There may be other example also. Twice minus x minus y, its whole cube, dy dx, and another part is 0 to 1, 0 to 1, y minus x. Same thing, twice minus x minus y. Same integral. I cannot change the integral dx dy. This is other repeated integral. So here, whatever this thing is, this is pi by 4, and this thing is minus pi by 4. So both the iterated integral exist and they are not same. So by Fibonace theorem, you can say that the function f is not integrable on your R. R is basically 0, 1 cross 0, 1. So some of the students gave correct answer to this. So I'm happy to get correct answers. Okay, so how this can be done? This is very simple because uh, if I take a different example, like if I take integrand function to be x square minus y square divided by x square plus y square whole square, and note that x square minus y square divided by x square plus y square. This is minus del 2 del x del y tan inverse y by x. And if we calculate it, then we realize 0 to 1, 0 to 1, x square minus y square. This will be 5 by 4. So, and 0 to 1, 0 to 1, x square minus y square, x square plus y square, whole square dx dy. This will be your minus pi by 4. Okay, so in this case also same thing, because both the iterated integral exist and they are not same. So we can tell that f, this f is equal to x square minus y square by x square plus y square, this whole square. This is not integrable on this rectangle R. Okay, so there is one correction I like to mention. This thing we have to calculate it, and we can show that these are not same. So this may not be your pi by 4 and minus pi by 4. So this is please try to show it. So immediately I am having two examples. Example one, maybe this is your example two. Example one already I did. This is your example two. 3, it numbering will be 3. Okay. Next. Next question is that can it happen? Remark 2. One iterated integral exists, but not the other. And this imply it may so happen the double integral also exist. You see, this is also happening. If you see the statement of Fibonace theorem, this also, it can also happen. One of the iterated integral exists, but both double integral and the other iterated integral may not exist. So I can give if I little bit careful to construct, let us construct an example and construct a supportive example. This is half whenever y is rational. This is x whenever y is irrational. On 0, 1 cross 0, 1. Okay. So in this case, what happens? 0 to 1, 0 to 1, f x comma y dx dy. What it will be? It will be half. And if we look at 0 to 1, 0 to 1, f dy dx, this and over r f dx dy these two things do not exist. So where f is having discontinuity, you look at whenever y is rational number on 0, 1, then the function is 1 by half, and whenever y is irrational number, function is x. So where the function is having discontinuity at infinitely many points, at uncountably many points, function is having discontinuity at its measure is more than 0. That means it is a positive measure. That means most of the cases, uncountably many points where the function fails to be continuous. Therefore, we can say that the f is not f is not integrable. So double integral f over r dx dy does not exist. And now why in this case, if we integrate with respect to y first, then in this case again function, in this function it is not Riemann integrable. If we look at that part, so it is not Riemann integrable, hence we cannot evaluate this part. But if we go by this direction, then this function becomes integrable, and ultimately we can integrate and we can get it 1 by 2. Okay, so this is one important example. Now another question. Can you construct an example where both the iterated integral exist and same but double integral fails to exist? Okay, so again, in this case, I like to allow my please listen to me carefully. If I ask you, then only you answer, otherwise not. Otherwise, if I report it, then definitely your negative marks will be there. Ranjan Kumar. Ranjan Kumar.
Yes, sir.
Please tell. If you cannot say the answer, try to tell whether it is possible or not.
Sir, nothing is visible on the screen.
You have listened my question?
Yes, sir.
Okay, so then what is the necessary thing that you have to see? Rahul, sorry, Ranjan Kumar.
Hello.
Yes.
Sir, I am unable to answer.
Okay. It's fine. Listen to me carefully now. And again, this is very surprising, but it is fact. It is a fact that it may happen. There is some example where there are some examples where we can expect that both the iterated integrals exist and they are same, but still double integral fails to exist. So this is quite surprising, but it may happen. It may happen. I like to give one example in this connection. Yes, it is possible. You can see the screen. You can see the screen.
Yes, sir.
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 Sir, may I give the
Sir, one doubt.
question answer,
Can I
sir?
give the answer one?
Can I give the
No,
answer, sir? Rahul Kumar.
Sir,
Hello. Now you can hear me.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So
sir.
you can see the screen, right?
No, sir. Screen is not
No, sir.
visible.
Screen is not visible. Screen is not visible.
Screen is coming.
Visible. It's still not visible, sir.
It is visible.
Yes,
Yes,
sir.
sir. Now
Yes,
it is
sir.
visible.
Yes, sir.
It is visible now.
Sir, one doubt.
It is visible.
Sir, video is lagging, sir.
Sir, one doubt.
Again. Okay, so the question was, can you construct an example where both the iterated integral exist and same, but double integral fails to exist? That was the question. So answer, it is possible. So I like to give one example. You carefully see the example. If I take f of x comma y to be xy divided by x square plus y square, its whole square, whenever x comma y not equal to 0 comma 0, it is 0 otherwise. Okay, so your r is minus 1, 1 cross minus 1, 1. If I give this thing, then whatever the antiderivative of this function, integrand, this is minus of x divided by twice into x square plus y square for fixed x. So what happens if we do the calculation? Then what it will happen? Then this function becomes an odd function. And if you do the calculation, minus 1 to 1, minus 1 to 1, initially your f dx dy, or if you do minus 1 to 1, minus 1 to 1, f dy dx, if you fix x, then you can get it. So ultimately this thing is going to be equal to minus of minus 1 to 1, this part, right? This is your odd function. This part is coming x square plus y square. This is dx. Ultimately it will come and it is going to be equal to 0. So similarly, for the other iterated integral, it will be also 0. So we'll get something like y by twice into x square plus y square. This is also odd function. Mm. So ultimately, if we integrate minus 1 to 1, this odd function dy, so we get it 0, right? So in both the cases, we will get it 0. Now, if we look at it, this function, whenever x and y not equal to 0, where the function note, f is discontinuous at only zero comma zero, but so at only 0,0 function is discontinuous, but it is unbounded near the origin. Why it is unbounded near the origin? Because you see, whenever xy both close to 0, the numerator goes to 0 and the denominator also goes to 0. Whenever x and y both very close to 0, then x into y also goes to 0, right? And at the same time, x square plus y square, its whole square also goes to 0. But we have to see the rate of convergence. And if we see the rate of convergence, then we'll realize that rate of convergence for numerator is just its rate of convergence quadratic. It is a multiplication. But in the denominator, if we see the rate of convergence, it is near about biquadratic. So it will go more close, more faster to 0 than that of the numerator. So ultimately, ultimate function it goes to infinity whenever that means near origin 0,0. So it is unbounded. You understand? Since the function is unbounded near the origin and origin is including the it is included in the domain of definition, then we can say that the function its double integral does not exist. So from that particular point, I can write hence double integral does not exist. Okay, right? So there are so many things already we get it. And I request you this note also I give, and I all of you please see the lecture note, whatever it has been there. Today I just uploaded one revised lecture note in this connection. So all of you please see it and then try to understand it. Another point I like to make, if you are having any problem, you just give and your seers, particularly seer, they are requested to give a collection of your problems so that it can be discussed in your tutorial class, right? Or maybe I can spend some time in the next class in order to understand it. Okay, this much for today. So there are two options. Either I will discuss in the next class, or maybe in the tutorial class it will be discussed your problem. So you please write the problems where you face difficulty. You are having the lecture note. It is in elaborative form. Everything it is there, and there are some parts you have to do at your own. So I am sure you will do it. You understand it.